My name is Remco Zegers. I'm an associate professor at the Cyclotron laboratory, and I'm working in the charge exchange group. And one of the devices that our group has built is this low energy neutron detector array, LENDA for short. And this is LENDA. It consists out of scintillator bars. These are these bars right here, which are connected to phototubes at the top and at the bottom. And we have a second frame like this one as well, so you only see half of the full array right here. The purpose of LENDA is to measure low energy neutrons, and it does so by detecting these neutrons in these bars. They are currently covered with plastic, but behind the plastics there is plastic scintillator, and when a neutron hits that plastic scintillator, you produce a little bit of light that gets detected in these phototubes right here, and a signal is produced that can be sent to a data acquisition system. It is specifically used to measure low energy neutrons. Now they're actually not that slow. They have still a velocity of about 3% of the speed of light. So that's still very fast, but in terms of nuclear physics it is pretty slow. And we want to detect these neutrons, and for that we need a very good efficiency of these detectors. And so this bar is very short, because if it would be longer then we would lose a lot of the signal. And these phototubes are also ran in a special way so that we can keep most of the signal maintained for the acquisition. The main purpose of the low energy neutron detector array is to measure the PN reaction in inverse kinematics, that is a charge exchange reaction. The way it works is that we have a target which is built out of hydrogen, liquid hydrogen to be precise, and a beam from the cyclotron can hit that target and produce all kinds of reactions, but we are particularly interested in the reactions where a slow neutron is produced that we can detect in this system. In addition, a second particle is measured that is done in the S800 spectrometer, and by combining the signals from the S800 spectrometer and from the low energy neutron detector array, we can learn something about the PN charge exchange reaction. One of the motivations for doing these experiments is astrophysics related. So the reactions that we can study using the LENDA array are important for understanding what happens in a supernova explosion, and so they can provide us some of that information. The low energy neutron detector array is constructed by the charge exchange group, so that's the group that I'm heading. It consists out of several students and postdocs, and they have contributed to the building of this device, and it took about a year or something like that. And we ran the first experiment in October of 2010. And we are currently analyzing the data. The device itself worked very nicely. We could detect the low energy neutrons very well. And soon we will have that data analyzed.